My name is Jared McCabe. I'm a senior designer and assistant scan manager at VAA. I've been here for just over a decade, and during that time, laser scanning has become more and more prevalent. And in the last 2 years, we've started scanning ourselves. So today we're here to talk to you about what we've learned over that time to help you be successful with scanning.
And yeah, good afternoon, everyone. My name is Robert Deerdorf. I'm the BIM manager here at VAA. I've been able to see a lot of growth. I think maybe 12 years now. We saw our first laser scan on our first project. So we had to react pretty quickly, figure out how to use them in the most efficient way. The point of this presentation is to help you not just understand the value of laser scanning, but also how to get a good one, how to make sure that you have a successful outcome when you order one. That's hopefully what we're going to get across today to you. So what is a laser scanner? Yes, it says right here, non-contact devices that capture millions of discrete data points to measure objects or space using infrared laser technology that produces detailed 3D images in minutes. Kind of complicated. We have a laser scanner here. Try to talk loud. The way this works is there's a mirror right in the middle here. There's actually a laser inside. The laser comes out that mirror. This thing will spin, and really, really fast. By the way, it'll sound like a very angry cicada that's running at full speed, and then it will spin around either 180 or 360 degrees, depending, catching everything within line of sight. Line of sight's important. We'll get to that in a second. So in essence, what it's doing is it's basically measuring and creating a replica of what it sees using millions and millions of points. And you kind of see the points in the picture on the right. So here is a laser scan. As we go through this, I'm going to try to kind of define a few terms for you so you can understand what's going on. If you do end up ordering a laser scan, you'll be able to speak a little more intelligently about what you're talking about here. A laser scan, maybe you've heard of point clouds too. The reason I'm saying what a laser scan is because it's not a point cloud. The laser scan is just the act of capturing the data. On the left, you'll see this is actually a laser scan. That's an image that's created by the scanner. Below on the right, you're going to see a map. That's like a plan view, what the scanner sees at eye level. And go to this next screen here, you'll see on the top right, all the points. I tried to zoom in. This is actually the conveyor on the left, just zoomed in on it. So just to give you a better idea that it's just a bunch of points. That's all it is a bunch of measurements. It just looks very much like a picture when you zoom out. Resolution is important to understand. Every scanner has settings that allow you to change how many points it's capturing. The resolution is typically about 30 meters or 30 feet, 10 meters from the scanner. And you can go anywhere from 2 millimeters on center to up to like 15, 20 or whatever. The higher the resolution, the more details you're going to be able to see in your scan, the longer it takes. So I mentioned line of sight earlier. Here's a picture of the same scan we just showed, but off to the right a little bit. I think, yeah, so you'll see all this open area here. Basically, line of sight, can't see through things. It's not an X-ray. Even if it was, X-rays won't be able to scan through everything. So when you have missing data, laser scanners are used multiple times on a site. As you can see on that picture again on the right, there's a couple of scans in here. So what we did in this site is we move over to the position. If again, look at that mini map on the bottom there. Now we're kind of in the northern scan spot. The other scan was roughly where that red X is. And so to define overlap is the data that multiple scans would see together, the same things. As long as they see the same things, that's overlap. Overlap's really important because laser scans, when you register them, another term, sorry, registration is lining up each scan onto another scan so that all the data is actually accurate. It's kind of like surveying. In order to do that, you need good overlap. One thing you might notice in scans from most people is if they're not doing a very good job, if they spread out their scans too far, they won't be able to register it well. And we'll go over some examples of what that looks like later on. But in this case, there's a lot of overlap. You can see the conveyor, you can see the platform, there's walls around, lots of this stuff that these two scans are going to be able to see and allow us to do a good registration. So if we go back, this was that original scan. And after registration, there's the points kind of just stapled right on. Again, the accuracy in terms of registration, that's going to be within probably like a half millimeter.
Is that just the first scan that you had the red X?
Yeah.
Not with the second one?
This is this is the first scan, and then
Okay,
this is stapled together with the.
half the two of them.
Yep. So this is
Okay,
two
yep.
scans here.
Gotcha.
And you'll notice that a lot of the areas where there was missing information, like not just down here, but up on the top,
Yep.
you have filled in information.
Yeah.
So, with that being said, the image on the left, take a look at that and ask yourself this question. How long do you think it would take for you to measure and document everything you see here in this picture? And just so you know, this is actually not a picture. This is another image from the scanner. Scanners do color sometimes. It depends on the setting, and Jared will go over that a little bit. I kind of made a list for myself, but I look at this and I go, there's a lot of round things, a lot of radiuses here. That gives me heartburn when I'm trying to measure things. I see elbows. I see gourd elbows. I see a whole bunch of conduits on the ceiling. I guess I'm going to have to go get my ladder. I see some pipes that aren't necessarily orthogonal, perfectly vertical. So I'm going to probably have to figure out, maybe I can use the floor as a reference to give an angle, except maybe the floor is not level. How am I don't know. It's going to take a while, right? This scan, what you see, this is actually, again, the scanner does typically a full 360. So this is only a part of it. This took about 60 seconds with color. It's actually about probably 30 seconds without to capture everything you see here. In this floor, the floor plan on the right, there are 17 scans. Took us approximately an hour and a half. And you'll see some spheres. There's actually, if you look at the bottom right, there's a sphere. We'll talk about that later too. Those are targets. You see them around the room maybe. There's some paper ones and some cool looking ornaments. They're not Christmas ornaments. If they were, they'd be the most boring Christmas ornaments ever. But it took us an hour and a half to capture this whole floor. Now, one other question is, how much did your last change order cost potentially? Just consider that, because the cost of a scan will come up next.
Well, like Robert had said, trying to measure something isn't always going to go well. It's the old way of doing things. And in my time here, I have a boss who has absolutely terrible handwriting. It's sometimes he can't even read it. So it makes it really difficult when he brings it back to me and I'm like, is this a 7 or a 9? And he's like, I'm not sure. I did this last week. I've already been thinking about other things. So if I start putting in columns and they're at a 17-foot spacing, but they're actually supposed to be at a 19-foot spacing, that's extra rework for whoever's out in the field trying to get it to come together, and it just looks bad for everybody. Additionally, we went and did a presentation at a college and kind of challenged them to do the conventional method compared to what we had. Split them up into 3 groups. We gave them different tools. We gave one a 10-foot tape measure, one a 25-foot tape measure, and then another team we gave a laser disto. We gave them all the same thing to do. We want the width of the room, we want the height of the room, we want the location of the door, and they all came back and they all had different answers. It was pretty simple things, but maybe they measured from the bottom of the wall to the bottom of the wall, so there was some trim involved, or maybe they measured from the left side of the room to the right side of the room, and in case you didn't notice, walls don't necessarily go in exactly straight all the time. Maybe there's a little slight curve to them. So you end up just not having the best information. But with new technology, it really avoids all of that, all of those challenges that we've typically had in the past.
So that question I asked earlier, how much was your last change order? We're going to go over the cost here a little bit, just give you an idea, a rough idea, because it is a concern. It's not the typical method. So as an idea, we've done 20 scans so far this year internally, and they've ranged from $615 for local scans up to $50,000 for remote full facility scans, and I average about $12,000. So if that number is equal to or less than a change order, you might want to consider a laser scan for your next project, and I'll go over that right now. This is the cheat sheet we use internally, because again, we do scan, so we like our project managers to have at least an idea of how much it might cost without it coming to us first. And yeah, basically, these aren't necessarily indicative of like a whole facility scan, like I said, could be $60,000. So it's obviously going to be, instead of 300, it could be up to like 1,000 scans. But most of our scans, I think, are what, 200? Roughly around 200. So just an idea. And we have approximate square footage. So it's just a nice little cheat sheet. Again, don't take this to the bank, but this will give you a pretty good gut feel of how much it might cost.
Is that thing able to work out in sunlight?
Yes.
And are you limited to how many feet away?
We'll get into that a little bit later.
Okay,
but,
sorry. I always ask questions before I share.
That's totally.
I'll shut up and listen.
Believe it or not, this
Especially
this can work in pitch black, actually.
Wow.
Because it uses infrared laser. It won't capture color in the dark though. It'll be nice and black colored, but yeah, it can scan in the dark, so it's pretty nice. So yes, I asked this question. Let's talk about the benefits other than potentially.
I think it avoids change orders in my mind. Right?
That's the hope, yes.
Yeah.
He's actually a secret presenter with us.
Yeah.
Hey, like I said, I worked on a project you guys did, and it was unbelievable.
So we appreciate that.
Let's see you slide him some cash.
Yeah, exactly.
He gets out of the.
So I have a few things on this slide, but I also want to talk about something else. So typically, yes, we're a little ahead there, but reduce change orders. It's not going to guarantee no change orders, but it's going to help you potentially reduce them. And based on costs, I'm going to assume one, you probably have paid for your scan. Improved model accuracy. So this scanner right here at I think 500 feet is within 0.1 millimeter accuracy, meaning you can say within 1.1 millimeter, which you probably aren't going to be able to measure on site anyway. You're good. This one actually scans 1,300 feet. So this is one of the best ones you can get. We love it. It's our baby. It's our baby. We're nerds about it. But yeah, so improved model accuracy. Capture everything. It's going to be very accurate. This also, having all of this accuracy allows you the ability to plan ahead a bit more. When you can see everything that was going on in your plant, not just the stuff that somebody measured, they probably missed something. Now you can, if you're using Revit like we do, you can model a piece of equipment and actually see if it's hitting something and not just not hitting the things that were measured. And all of that ends up leading to reduced installation time and shorter construction schedule, which of course time is money, so it's just double money. Moreover, though, the one thing that's kind of a side note is the modeling. So the actual Revit modeling or AutoCAD modeling with Point Cloud is so much easier. You're basically taking the game of telephone out of the equation because you basically bring it right into your software, cut your plan, if you will, or a section. You can see everything. You can just draw right on it. You're not going to miss anything unless you're just not paying attention.
All right, so there's a few different times when 3D scanning is super, super helpful. And the first one being complicated tie-in points. This is an image taken from the scanner, and there is a lot of stuff going on. I've been here, like I said, for 10 years, and I can count on one hand the amount of greenfield projects that I've ever worked on. So we just don't get to have easy projects almost ever. We're almost always trying to fit 10 gallons of stuff in a 5-gallon pail. So when you have complicated tie-in points, the more information you have, the better. I've been to many sites, I've taken many photos, but I never get enough photos. I never get enough dimensions. But with a scan, you're going to be able to capture more data. Probably where's the drawings?
Oh, we didn't have any existing
Oh
drawings.
yeah, that's right. Sometimes we don't have existing drawings.
That was good, guys.
Sometimes fires happen.
Nominee.
Sometimes floods happen, maybe sales happen of the facility, and they didn't exchange hands and they just got lost over time. It's really hard to start a project when you don't have a starting point. You're all here for ski fly. Doesn't really make sense right now, but if you don't know what it is, it's a kind of crazy winter sport where people go down on skis and launch themselves into the air and
Wipe out dirt.
I mean, yeah, it's nice. We had an opportunity to go out and actually scan this ski jump that you see on the left.
Terrifying.
Yes.
Is that Bloomington?
No, this is up in Michigan.
Oh.
But while we were out there, we learned more about ski jumping. And the reason why this was so crucial is they were trying to rebuild this. It hadn't been used in almost 2 decades, and they wanted to get it ready for tournament and have some really cool events out there. They had some existing documents, but some changes have been made since then. And so the document or the black lines that you can see in the right-hand image is what they thought they had or what was documented. Then in red is what the scan actually showed. Now, you can see it's moving. It's exactly. The launch angle needs to be at a certain point, and they need to stay hovering at less than 10 feet off the ground at all times. So if they thought they were launching at this angle, but in reality they were launching much lower, they could have had a fatality, serious injury, or something like that. But due to the scan catching it early, we were able to avoid all of that. Which leads right into when should you order a scan. The earlier the better. And it's going to depend on the project what type of scanner you're going to use. But somewhere between the concept phase and the design phase is generally when you're going to catch the most design flaws and factors and what's most useful. And I'll hand it over to Robert to. And so this 3D scanning isn't for just contractors, engineers. It's for the entire project team. So owners, you're going to get an overall project that's going to be better for you. You're going to get exactly what you paid for. Contractors, you're going to have less rework, less frustrations out in the field. Designers are going to be able to create what they need to, work with the engineers, coordinate better, work with the consultants. The entire team is going to benefit from having just more information and data to go.
One thing I forgot to mention is another thing for owners and contractors, you'll have less consultants revisiting your site multiple times to capture those measurements that they forgot. So less safety issues and less pestering. So it's not a bad thing. So now hopefully you're intrigued. Hopefully you're considering, I'd like to maybe do this, but I need to know more. This is where we get to hopefully prepare you for actually ordering a scan and help you understand what you want. There are multiple types of scanners. So I'm going to just lay them out and kind of show you how accurate they are and what they're used for. Drones, great. If you ever the term catch it or look at it from a 10,000-foot view, that's exactly what you're doing here. They're great for capturing huge swaths of data and doing it very quickly. Cons, they're not very accurate. I'll show you an example. But these are more for knowing roughly where a building is on a site. And you can't usually use them indoors. That's another problem. Here's a scan that we've had done. We don't do drone scans ourselves, but we had this done on a project, and it looks pretty darn good from a 10,000-foot view. This on the right is actually a column that's, if I cut a section or a planned section through that tower, this is the column. Now, as I mentioned, laser scans are line of sight. They hit the face of something. So all those points you see are actually the same face of a column. That means we can only locate this column within 5 centimeters of where it actually is. We don't know where it is in that mass of points. So this is just an example. The next one, this would be the lamest looking one or the coolest looking one, depending on who you are. The one on the left looks really cool. The one on the right, I don't know. We didn't like this, just doesn't work with our fashion at VAA, but SLAM, which I have to look because this is a ridiculous name. SLAM stands for Simultaneous Localization and Mapping, which is just a fancy way of saying it moves and it scans at the same time. With that in mind, the pro of SLAM scanning is that you can capture things really quickly because you can just walk through a building, hold it here, you're scanning. They're a little cheaper sometimes than maybe like a fixed scanner, which is this. Yeah, basically the pro is it's fast. And I guess one other pro is that because of their handheld, you can get into tighter spots that you couldn't necessarily get in with this easily. Downside, again, it's not as accurate as as the fixed scanner. It's much more accurate than a drone scanner because you're scanning closer. That's the biggest difference between the drone and this is that the drone's scanning from really high. They use pretty much the same technology for scanning though, because the drone's also always moving.
So on those drones, if they get and just hover, let's say it's 150 foot high, bucket elevator tower max, whatever. And if they're at 200 feet, is it get more accurate? If they're lower?
This picture was done with the drone right next to it.
Oh,
It's just,
so the answer is no.
it's,
Thank you.
it's moving, maybe the tower's moving because it's windy. There's a lot of factors that go
Yeah,
into
yeah,
the
yeah.
accuracy, so.
Okay, cool.
So registration, I didn't mention this earlier, but have any of you ever seen good old fashioned overhead projectors? Teacher has like the clear thing that they'll have like lines and then they'll try to line them up. That's kind of like the best way to explain registration, except it's in 3D and can rotate too.
Okay.
With SLAM scanners, there's not set positions like a survey. Like when you do a scan with a fixed, you got fixed positions, everything's static, unless people are walking around. But with this, the registration is much more difficult because you're just moving. So as you're moving, it doesn't necessarily know where you are. It's just capturing data as you move. So it has to be able to judge how fast you're moving. Indoors, it works pretty well because it's got a constant wall. But when you're up in the air near a tower like this, and there's just a few columns around you, it's harder for it to track its movement. And so that's one of the reasons why SLAM's not as good, especially on its
Okay.
own. But
Thank you.
yeah, no problem. So the final one is your fixed position scanner. So this is going to be the most common. If you just were to go order a scan from somebody and have them provide a quote, they're probably going to use this. This has been around for quite a while. Pros, they're really freaking accurate. Like you'll see in a second, but these get down to 0.1. I'd say most of these are around 1 to 2 millimeter accuracy at about 100 feet. Again, this one's 0.1. And they get down to about that. The range is going to be much greater. SLAM scanners are, like the non-drone SLAM scanners are maybe like 100, 200 feet. This can go 1,300 feet. Now, word of warning, I wouldn't trust the data at 1,300 feet. It's not going to have a really dense resolution like we talked about because you're so far away. But it's great for having just the idea of where you are because you can capture buildings. Our first scan with it, he captured a water tower in the town, so I could literally position the building using like Google Maps in the town. It was kind of shocking how far it scans. The other one nice benefit is, as we mentioned, there's targets around the room right now. Targets are used. It's basically the scanner can recognize that sphere, the exact center of it, and use that to help register. So rather than just using walls, floors, it can use points. So you can use, essentially there's like a satellite. You have 3 points. You can perfectly position yourself. So it lends itself to really good registrations. Downsides are fixed. They're the slowest scanner. Takes longer. They have to stay perfectly still. You can't have people walking up going, "Ooh, what's this?" and looking at it. You can't move it. You can't be on vibrating surfaces. If they're vibrating too much, it'll degrade the quality of your scan. And it is harder to get into tight spots. So as an example, here's that column that you saw from the drone scan. And here's a column from this scanner right here. You can see 5 centimeters, 0.5 millimeters. Again, that's multiple scans because obviously it's on every side of the column. So you can see it's very crisp and you can even see a dent. You can even see spider webs. I didn't see that until later, but at the bottom. So maybe it's time to clean your facility before we scan, but you can capture that. This is the resolution or the accuracy range that I've come up with in my research. So drones, you're anywhere between like 25 and 100 millimeters for your measurements. SLAM, you get down to maybe 4 up to about 11. And then your fixed scanners, 0.1 to 1, somewhere in there, or 1, maybe 2. And then on the left is an example of a fixed scanner, what you might see. And on the right is, again, there's a blow of that drone scan. So this is that same one I was showing you, but just more zoomed in. So all in all, I would recommend generally just to use a fixed scanner if you can. Yeah, it'll take a little bit longer, but the quality that you're going to get is worth it. Every single amount of, you might be thinking, oh, well, it's 1 millimeter, 0.1 millimeters. That's not a big difference. It's actually 10 times better. And when you're dealing with registration from one scan to another over the course of maybe 50 scans, you can be off by a foot if small little changes as you go. So every little bit you can use is worth it.
All right. So let's say that you are interested in getting a scan. There's going to be a couple of things that you should consider. What is the purpose of the scan? Is it just for avoidance and clash detection in a certain critical area? Are you just trying to recreate the existing conditions of your entire facility? On almost every project that I've ever worked on, a survey was done. These fixed scanners can be just as accurate as a survey, but they're going to collect a lot more data for it. Maybe there's a specific portion of the project that's critical. Say you have a tower that's up on top of your silos and you want to put a new bridge onto it, but you don't know if the tower can handle it because it's a little bit older. You don't have the existing drawings. So you want us to come out, scan, and make sure that we capture all of the framing, structural members, columns, beams, and that way you can bring it back, you can size everything, and let an engineering firm analyze whether or not you're going to need to beef it up or come up with a completely different method. Either way, you need to communicate what you're actually trying to do with the scan. That leads into how you might go about doing that. This is just a Google image that we took and started sketching on. We want this general area to be scanned, and sometimes Google has 3D images that you can sketch on as well. We want to consider all of this. And not every scanning company has done these types of facilities. So don't assume that the terminology that you use on a daily basis that they're going to understand. If I say leg head platform, most of you know what that is, but they might not, or what a color sorter is, or what the bin openings are, or why they're important. So communicate with them as to why you need this, and then they'll be able to quote it much better. There's a couple of questions that they're going to ask throughout the process of getting a scan. Color or black and white. Now, there's no accuracy difference between color or black and white. One might just look a little bit more natural, which might be beneficial for board members or people that have never been to the site and you're trying to showcase something. The other big benefit is when you use piping that is actually color coordinated. So maybe your sanitary and your gas or your sewer all have different colors. It makes it much easier to track which lines you've actually been following this whole time and reduces the amount of rework that you're going to have to do because you messed up.
So once you've defined your scope, communicated your needs, one thing you're going to want to talk to the scan company about is how you're going to get deliverables. There's, I don't know, 20 different laser scan manufacturers. There's probably 30 different file formats. The first thing you're going to want to ask for is a recap point cloud. Recap is the most standard. It's Autodesk. Recap is Autodesk software. So you want to ask for that. It'll work in AutoCAD, Navisworks, Revit. Pretty much all softwares will use it. Unified and non-unified, what that is, a unified is going to be basically be kind of decimated, meaning like the points will be thinned out and made more consistent, because when you do have lots of overlap, you have a lot of points on top of points. These files are very big. So unification kind of ties it down a little bit, brings it smaller, makes it easier to work with in Revit. The non-unified is going to be the full data set. You want that too, because you never know when you might need it. And then this is more optional, but I would suggest asking for E57 as well. This is a universal file or point cloud format that can be used in any other software. If you were to go back years later and want to add on to the scan and you use a different company, you could potentially send them an E57 and say, hey, can you tie that data in with this? And they'll be able to. There's other options. There's point cloud viewers. So what you see, the picture bottom right, that's a map. This is actually the Pharaoh scene to go, which was one that we use. This is a really easy way to view each of the scans as a 360 panoramic image. The image on the left you see here, that's actually just one of those scans. You just click on it. These can run with no programs at all. It's self-contained. So it's great for people who are not as tech savvy, but they want to hop in and look at what was scanned. You can still take measurements from these two, which is really nice. And then the next consideration is delivery method. So if you have a great internet, have a great computer, Doing it via internet's great. Like we do a lot of that. When we receive point clouds, we get a lot of them that way now. But if you don't have a great internet connection or you don't have a huge hard drive on your computer, you may want to be asking for an external hard drive. Again, for some facilities, when we go out and scan facilities, there's usually not great internet out there. So I don't know, some of you might not be dealing with the best. So consider that when you order.
So if you've received the quote, but you don't really know what the numbers mean and just want to do a back check for your own knowledge, there's a couple general rules of thumb that we follow. If you're walking the perimeter of the site and just scanning on the exterior, we want to do a scan about every 15 to 20 feet. So if you can use an existing plan or use Google to figure out that length that you need, you can figure out roughly how many scans it might take. And then there's a few different variations on how busy a certain facility might be. If you're in a feed mill and there's all sorts of equipment that you need to capture each side of, it's really dense in there. We want to do about one scan every 100 square feet. And then if you have like a wide open warehouse, but you're just trying to capture it, well, one scan every 200 square feet is going to get you the data that you need. There's going to be some expectations for before, during, and after. Before a scan, consider, is there any safety course training that the scanner would have to do? Can they do it before they get there? That way they're not wasting any time. Do you have any protocols in place where somebody has to follow them around? If so, like ask the scanning company, how long are you going to be on site? If it's 3 days, that's potentially 24 hours that you had somebody working, that they're just going to be following somebody around. So you have to figure out where those man hours are going to go. During the scan, I mentioned it before, it's line of sight material for line of sight scanner. If you have anything boarded up while you're out there, it's not going to be able to capture that. And due to liability reasons, they're not going to move that stuff. They're just going to scan what they can see. Robert mentioned it a little bit earlier, but running equipment, if there's a lot of vibrations, they might be asking you, hey, is there any downtime that's going to be coming up that we can try to time our scans in this area? Maybe we can shut it down, maybe we can slow it down and still capture the image that we need. There might be multiple people on site. Might be one person working the scanner, and there might be somebody else helping them out, moving the targets around, getting the next area set up. So you never. And additionally, none of these scanners, there's only one in the world that's intrinsically safe. So in areas with heavy potential for explosions, a lot of grain dust or sugar, they might have you shut down that area so that they can get in there safely, scan, and then you can start it back up. After they are done scanning, they anticipate about 1 to 2 weeks for a deliverable for the plant.
They never give us that long when we have these ordered internally. Next day, where's our point cloud? This is my favorite part because this is the nerdy part. But the best way to just determine whether your scan is done well, I mean, it's usually registration. Typically, each scan is going to probably be great because these pieces of equipment kind of run themselves. But depending on how well they do them and their layout and their technician at the end of the day doing the registration, you may not get something great. I'll say overall, you probably are going to get something good. I'm not trying to worry you, but I want you to be able to be your own best advocate in checking this. And if you don't have the ability or don't think you'll be able to, ally yourself with a consultant who can. Like this is something that, I mean, like again, we found problems in the past. That's why I'm going to bring this up. So you might look at a scan like this as an example where it looks great from pretty high up. Never trust what the scan company tells you. They'll send you numbers. All these programs will actually provide a big printout of oh, it was like 1/4 inch tolerance. It's great. It's all green. Yay. A lot of those calculations are based on, well, I saw a wall and I lined up and they were within 1/4 inch. But what if there was a door that was swung open and then it moved a little bit? And it is.
Like 118. Live now. Yeah, that's. Oh, no. Next door work test.
I'm sorry, I'm gonna wait 30 seconds. As soon as I start talking, another one's gonna come. No, okay, I guess we're good. Okay, so how would you go ahead and try to determine whether registration's good? My solution to this would be to cut some sections, plan sections or building sections, and use the walls generally to figure out if things look like they're lined up. So here's a plan of this scan. Now, because again, line of sight, all exterior scans are their own, all interior scans are their own. They tie together through doors, hopefully. They hopefully didn't crash to the wall to do this. It's tough to see from this high up, but if you look closely, you'll notice on the right, there's some columns that seem a little off, right?
Yeah.
If you don't know much about buildings, maybe you wouldn't see this, but again, you have somebody that can do this. I'm gonna zoom in and take a look. So remember I mentioned the overhead projector? The teacher didn't do a very good job here. You can see the exterior scans. There's two shadows. Essentially, there's two of the same thing. That means they weren't lined up. They weren't registered properly. Worse is the fact that the interior and exterior columns are not lined up. So that's really bad. I think when I measured this was like 5 inches or something. And then you also have the interior alignment issue as well.
Was this one that you guys did originally and you learned from?
This was not our scan.
I'm just checking.
I will not name who did this. But it was nice because again, when we saw this, we just went back, we just called them up, said, hey, we noticed some issues, and they fixed it. There was no drama. It was just like, oh, we're sorry. These programs will do stuff automatically, and good scanning companies will learn quickly that they have to actually check their work. And it's really simple. Like it takes usually like 2 minutes to cut a section and be like, oh boy, something's not right here. You can see this one too. You have multiple layers on the inside. This one's not just off in one dimension, it's off in two. And then the exterior again, lots of haziness. So yeah, basically the goal is if you see something like that, just call right away, get on the phone, say, hey, registration's off. If you can take snapshots, send it to them. Usually, I mean, maybe one every 20 scans, I'll see something. It's just better to catch it right away than halfway through the project, you realize that at one critical juncture between the two buildings, it's off. And then maybe everything over here was fine, but everything over here is maybe a few inches off. So just check it and contact the company and they'll correct it for you.
So do you have to go back and rescan it, or can you fix it from the data in the file or whatever
You can fix it. It's just registration. So it's literally usually
It's the 2 week time that you need to make sure it's right.
right.
Internally, they say we want it tomorrow, but you need time to do the cut section.
Exactly. Yeah. It's good.
The data isn't bad by any means. It's just the communication between scan 1 and scan 2 they're not communicating. They're thinking that they're 13.2 apart, but really they're only 13 feet apart. And they just need to basically sync those two together, tie in different sections, and then they'll be able to realign and look better.
You guys have to go and stitch the two, like the scan 1 and scan 2 together.
That's part of the registration process. If we're doing it ourselves, yes, we'll be doing that. But if somebody else does a scan, we'll just tell them that there's something wrong and let them fix it.
And I can give a little bit more background on this issue. What this was is, again, we talk about overlap between scans to get a good registration. When they went through from the outside to the inside, they didn't scan right in the middle of the doorway. So if you open a door and stand, 4 feet outside and look in, how much can you see? Your angle of view is pretty limited. And then the same way on the other side. And when you're scanning from the inside out, and there's nothing out there except for field, there's no planes to work with. So the program has a really hard time. So when I saw this, I actually looked to see where the scan locations were. I said, hey, can you guys just go add scans in these doorways? That'll probably fix your problem. And then we got it back, it was fine. So that's the importance of overlap.
So to fix that one, they actually had to go back out to the site that you're saying.
They did. They may have not had to. I asked them to just to make it even better. they could have probably got it lined up manually, but it's better to do it right with scans and let the program figure it out than have to manually fix it, because you'll never get it as close as the program can.
The scans are going to be useful regardless of what type of facility that you work in. For example, maybe you work in a brewery. You had one of those. It was awesome. It worked out great. Maybe you're in a food processing facility making my favorite food, macaroni and cheese. It's useful there. Maybe you're in a feed mill making food for dogs. Who knows? Or maybe it's a typical grain elevator. They're all going to scans are all going to be useful in every single scenario. They're going to capture a lot more information than we've ever had in years past and just give you a better design. So, in summary, scans are going to reduce your headaches, frustration, hopefully your costs, and the duration of your projects. You're going to capture a lot more data that you didn't even know that you needed and give you a lot of confidence in your design.
Can you see what happened to that building?
It caught on fire.
That was an interesting scan.
So they had a fire. We went out to try and scan it, and it was a successful scan. But when we got back, there was actually a number of issues with the existing drawings that we had, where we thought a tower was over here, but actually we were 5 feet off. The bridge was at an angle. It wasn't level like we had in our drawings. So going out and getting the scan significantly helped us in these.
So now you're up.
Well, in summary, what I'd like to say is, about any other scan company, you just come to VAA.
I didn't say it.
This is not a sales.
And the winner is.
Can you continue to build on scans? So like, in your first slide, you had those tie points that are difficult.
Yeah,
So you do those tie points and then you come back and build off that existing scan to verify.
absolutely. So you mentioned it at one point, why you asked the scanner for the unified version and the ununified
E57.
or the E57 files. Any scanning program is going to be able to use those files, and 5 years down the road, maybe we'll tie in this other area that we didn't scan because it wasn't necessary at the time, but we can tie them together.
And to add to that, if the building or the structure changes dramatically between scans, it may not work very well, because again, the overlap, the same geometry may not exist. So depending on how you do it, it might be difficult. And at some point, you probably want to rescan the new area, but yes, you can.
Good question.
Where you had like early on there showing layouts of where you're setting up for your scan to try to avoid the shadows or whatever you call them. Is that just experience on your guys' part, knowing where it's set up, or because you don't really see any of that in the field as you're doing it, right? You scan it, but you don't know it.
Yeah, so it's a little bit of experience based. It might look a little weird, but when I am actually out scanning, I'm literally doing this. I'm seeing what the scanner's gonna see, and if it's not a good spot, like I know that they need this bucket elevator, but for whatever reason it's blocked here, I might move it to here to get a better vantage point. And as I'm going around, I'm not only considering that, I'm considering making sure that I can see the targets that I've placed out there so that we can get the stitch come together really well.
And actually with this scanner, and some of the newer scanners, we have a tablet that it sucks because we have to basically walk around with a tablet. But the beauty is we get real-time feedback. We can actually spin the scan right after it's done and it registers it on site. Our first scanner that we bought, it was basically me at 2 o'clock in the morning, because I had just got the files from the scan person on site, making sure that it was good before the next day, because I didn't want them to come all the way back and then have to send them all the way back in. But now they're on site, they can see what they actually scanned and basically have that confidence before they leave. So good question.
Yeah, mention the difference between the static scanners and like the SLAM or drones. Is it just due to the fact that the drones, even when they're hovering, are moving a little bit, or is there some kind of way that the static scanners, GPS or something, know where they are physically in space?
So this one does have the ability, if you're outside, it can use satellites to actually coordinate how long you've moved. It tracks it a little bit, but yeah, when you're moving and measuring, and if you just think about it, if you're trying to capture how long this wall is while you're walking right here, you're not going to get a very accurate measurement. It might be close, but there's going to be some differential while it's moving.
And yeah, it's that, and it's based on the fact that it doesn't ever stop. So it doesn't say like, here's a set point. This is scan 1, this is scan 2. It measures, and every once in a while I'll just kind of put a stamp down and take a picture. So you'll see like for this scan, you'll see dots. Each one's its own spot. On a slam, you're gonna see dot with a line, dot with a line. So I'm not 100% sure on the science reason why, but it's basically because it's moving the whole time. It never stops measuring until you just tell it to stop.
You guys build on those, like, you do a slam and then you guys do a fix and build on those point clouds, or you guys do separate?
We don't actually use SLAM here. This is our second scanner. This was a big upgrade over our previous one. We've looked at some SLAM. The cost to benefit ratio for us isn't really there yet. But you can tie a SLAM together with one of these.
Just
Again,
as long as you have the correct file type, you can tie any of them together.
yeah, and it would be, again, like I only see us using it if we went to a facility where there's a couple really tight spots. We just have it in our back pocket. And we say, okay, we're not going to set up in here. We're going to walk in, get that scan, come back, and then just add it on at the end.
So there might be an opportunity where we want to get the existing conditions of the entire facility, but it's not super accurate or super critical for the actual project. So we might have a drone go out and do that. And we might just scan with this in the very critical areas, just so that you have a more fully developed area of what you're looking in. So it looks a little bit better rather than just having the owner look at a boot pit rather than the entire site.
You mentioned you have an iPad type laser that you use as well?
It's more so it's communicating between the two. So
Oh, okay.
after the scan is done, it's downloading it and it's trying to connect or register.
Show you what you
with,
have.
yeah, and so that I can be like, all right, well, I'm not seeing the face of this. Maybe I need one more scan here.
Ah, cool. Okay.
I'll
Real time. basically.
It literally reminds me of my dad. You know, like when it's reading your room, like it doesn't understand stairs, like that's what your iPad's doing, right?
Yeah.
It's pretty much telling you in true time where the walls are and stuff.
Yes.
Yeah. Yeah, the vacuum, all your smart vacuums, yeah.
Roomba.
They read moves while they're moving.
We do it the old fashioned way.
Your wife?
I'm gonna tell my wife you call her old fashioned. Thanks, Chad.
Keep her away from the Jeep speed.
Yes.
Everything we've looked at in structures, have you any experience doing site contour?
It captures some of that, but we don't generally use it.
Yeah, I mean, so one thing that you had mentioned getting this, not as a survey, but along with, one thing to note is a scan can never replace a survey in terms of you can't have it signed. It's not signed by a professional. You can though model the contour from it. But if you were just trying to find that information, I don't know what reason you'd want it other than to have it, I guess. But if you're going to need that, you probably need to go survey anyway.
We've gotten the drones stands, we've gotten surveys of drone stands that they've been able to serve.
And
But be very careful of that. You might want to have somebody look closely at it because they can be drastically off.
Well, you don't really have hard corners and edges and planes.
Yeah, maybe there's crops in the field, something to tell how the actual.
So a note that kind of builds on your question, though. I think maybe within our last 10 scans, we did a scan at a project that had a recent survey done. And we were able to, as long as we can know where the tie-in points are, we basically had the people on their facility go, we took the survey drawing, highlighted different tie-in points that we knew were going to be in our scope, had them go out, make sure they were actually there, take a picture so we could find them. And then I had the scan tech go and make sure he sets up really close and does we can tell the scanner like, hey, for this little area, do a really high density. And then in the software, I put those points in at their survey locations so that when the scan gets registered, then I can tie it into real world coordinates. And then now it's survey, like it's tied to the survey. So you could go into the point cloud and point to something and actually get the real world coordinates. You couldn't necessarily sign off on it as a survey drawing, but you can tie it in with survey coordinates, which can be really useful.
So some of you guys know Dan, he started his own company, right?
Mhm.
And he told me that they've been doing some roadway scans that are survey certifiable, rather than having to go out with trucks and different, markers. I mean, I don't know. It's probably accurate enough there because you're within 5 inches or whatever you were saying. I mean, I don't know.
Yeah, there's a ton of different uses for technology as a whole. Like if you go onto the Faro website, one of the main selling points is crime scene record. So they will scan the crime scene rather than take a bunch of photos. So there's all sorts of uses. We don't necessarily use them for all of them, but we use them for our applications, and it's been working out great.
Certainly not crime scenes.
Yeah.
Although it's not an idea. What's it gonna cost them?
I know that you're improving your technology around scanning and then applying it to modeling. As an engineering firm, do you see yourself now creating more drawings for projects that people are constructing off of, like scope drawings and piping drawings? Any issue for fabrication level type stuff?
We've had some requests and we've done some of that. I think more so our entire project scope is just more complete and fully designed. Any new connections that are going to be there allows us to give you better, accurate drawings that reduces the field requests or RFIs. And
It does, it's certainly like having a laser scan and then some of the software we use, like we have a software called Edgewise. Yes, thank you. Edgewise will take a point cloud and automatically to 80% process all cylindrical data, so pipes, conduits, and model that for you. And then you basically go through and clean up the last 20% and it will get it within tolerance for fabrication. What we would send out internally, of course, would be varying from that, and the contract wasn't written because it takes a lot more work to do that. But I know we've had requests. I think we might have done a few, especially like with steel weights and extracting steel from a point cloud. We've done some of that internally. I think Trevor. Yeah. So yeah, but yes, we're seeing an increased desire for that, and I know our skills are getting to the point where it's a little bit more common for us to maybe do that. I'll say it would be really hard to do that without really good data. Actually, first, go ahead.
What are some typical file size ranges for these point clouds?
In the gigabytes. I just copied one today that was 60 scans and it was about 60 gigs for one scan. And usually like the non-unified one would be about 60 per 60, maybe a gigabyte per scan. The unified one that most people would use is about 10 times smaller. So, and then the viewers maybe about 15 to 20% of that. So it's big. That's why I was saying, depending on your internet connection, you could spend a good day or two. And then of course, if it fails halfway through, yeah. So maybe ask for a hard drive. But
I do have a 10 terabyte hard drive in my computer and I have filled it once already. We go through a lot of data.
Yeah, they're big.
What about in reflective environments?
Good question.
Yeah, so that's a question that a scanning company might ask you. Is there going to be stainless steel? It is reflective, but there's certain settings that you can go on, and not just the resolution, but like how slowly it spins and how much data it's actually capturing. So they might have to be out there for a little bit longer in shiny applications. But it is able to capture it actually on the slide that showed the column in super high detail. That was a stainless steel column that after filters and cleaning it up, it looks very, very.
Now, and to build on that, reflective, like mirrors in water. No, you're gonna see whatever you see in the water. We've had spheres out in parking lots and then a puddle of water. And my program picked up a sphere underground because it saw it in the reflection. So if in scanning, like commercial applications, if they have a bunch of windows, there's a lot of the actual manual cleanup that we have to do at the end. The other thing about scanning is, so the surfaces, the whiter the surface and the whiter and the more matte the surface, the better reading it's going to get. Every scanner will have a data sheet that kind of tells you, like, here's how accurate it is with a 90% reflective. And what they mean is white. How white and reflective of light is it? Really accurate. And then the darker it gets, the less accurate it gets. So if you have really dark, shiny equipment, it's going to take the scanner more time to get a clean read on it.
You're in a boot pit, it'd probably take a little longer, huh?
Depends. Dust can be great, not in the air. You obviously,
Sitting on the top of
if you scan in dust, you literally have a point cloud. It's just a cloud of points with no definition at all.
Generally in those tight areas, it takes longer because you're trying to maneuver through a very
Sure.
tight area and getting this set up to be level enough to actually scan.
And kind of on that, you mentioned dust just now. How dusty can it handle? I mean, does it need to be pretty clear air? I know it's kind of a.
Yeah.
It's a loaded question.
Yeah.
Yeah, so if it's a very dusty area, like a truck just came through and got loaded, and dust is going, I would maybe hold off for a couple minutes while the dust settles and then scan through a truck lane. But if it's just consistently dusty in there, you can still scan, you can still get a lot of data. There just might be some extra filtering or cleanup that we have to do on the registration side in order to get it to look the way that we want it to.
And it's kind of what I was worried on the software side, or is it actually the scan's just?
It's the scan it's just going to capture it. Like you saw the cobweb on there. The laser's going to hit that dust as it's falling to the ground, and it's going to capture that data. We just need to clean it out then.
Yeah, we learned the hard way a year ago on a scan where there was quite a bit of dust. I didn't know there was going to be a lot of dust. When we got the scan back, we don't usually look at the 3D scan right off the bat. We're looking at it's like a 360 view. We're trying to extract the spheres, right? And normally, like our old scanner, this is our old scanner, we get extracted within 60 feet. If they're within 60 feet, we can get them. And I was finding ones 20 feet away. I'm like, why is it not working? I spent probably 30 minutes trying to extract these. I finally look at it in 3D and find out that the distance that it was scanning was only about 15 feet because the intensity of the laser was shooting through all the dust and losing its ability to read. And so not only does it not capture data very far, but then registration becomes pretty difficult to make accurate because you don't have as much data. So, you can scan in dust. It's better the less you have, the better data you're going to get. So.
They have a software now where you can take a point cloud, just push a button and make it a model.
There
a bunch of time.
There's some technology out there that allows you to not just push a button, but it can do simple things like walls, some beams, some columns, talking with edgewise, maybe some conduit piping, but not just create the hammer mills that you might see or do any of that. It's very basic information at this point.
So, and there are scan to mesh software, so it'll make a big block that roughly is close to the shape. But as a Revit user, that's my main thing I used to do. I'll say that if you find that, and maybe you're ordering a scan to say, hey, we can do scan to mesh. It'll be super fast. You'll have this beautiful model. Don't forget how usable it may or may not be, because we've had models come in that were modeled. They look beautiful, like everything was there, but you couldn't modify them in Revit, which means when it comes time to make modifications, we have to remodel the whole thing. Maybe you don't care, I don't know, but at the end of the day, like, we do have to look at that and say, wow, we can't use this, or it's so big that you can't use it in design software. So yeah, there are programs like, again, Edgewise can go through and use an algorithmic AI to figure out a lot of that stuff, but there still requires a lot of user input. I'm going to guess within the next 10 years, there probably will be something out there that can do this a lot better. Just with some, like the one that he mentioned where you can extract a beam. You just load into Revit the size of beams that you would typically be thinking you're going to see in a project. and you click on one end of the beam and the other, just on a face. And then give it about 10 seconds and it'll say, oh, it's this size and model it for you. So it can speed that up a lot than just doing it manually. But yeah, there's not a fully automated solution yet.
What's that unit cost?
That one,
6 figures, 100,000.
100,000. The best conversation we have with anybody who wants to scan, like, all right, don't drop it.
Yeah.
Don't drop it. Also, the first scan, the bird pooped right on it.
Oh, no.
Yes. Guaranteed to happen.
Inside a flower bin. No, I'm just kidding.
No, it was cold and the food froze almost immediately.
Great question so far.
Good presentation.
Good. Thank you all for coming. Ken. Appreciate it.